Welcome everyone. Today we are going to do a deep dive into one of the most critical but often misunderstood aspects of Oracle EPBCS, and that is block storage architecture that sits at the heart of Essbase engine. Whether you are an EPBCS administrator or planning architect or a financial analyst who wants to understand why your calculations are slow, this session is designed specifically for you. By end of this video, you will clearly understand what dense and sparse dimensions are, how data blocks are physically created and stored inside EPBCS, how intelligent calculation works, and most importantly, what happens when you get the design wrong. We cover four main areas in this video: dense versus sparse, block creation, performance impact, and best practices. So let's get started. We will be using a real world demo application called EPBCS, which consists of 10 dimensions, 2 are dense and 8 are sparse. I'll be sharing the application in a moment. Every concept we cover today will be illustrated with actual dimension names, real business scenarios, and working business rule code from this application. So as you can see on the screen, the application name is EPBCS. So let me take you through the list of dimensions present in this application under OEPFS cube. We'll be using this cube for all our demo purpose. Okay, so these are all the list of dimensions which are present under this cube. Let's see how it has been set up. So as you can see, the account and period dimensions are marked as dense, and the rest all other dimensions are marked as sparse. So hope the application structure is clear. So by end of this video, you will understand exactly why each one belong in its category and what happens if we put them in a wrong bucket. Let's understand all the dimensions present in this application and why it is assigned as dense and sparse. Every dimension in our EPBCS application falls into one of the two categories, either dense or sparse. I want to be clear. This is just not a label, right? This decision directly controls how Essbase uses memory, how it stores your data, and how fast your calculation runs. Let's start with the dense side. So in this application, we have two dense dimensions, account and period. So as you can see, I have highlighted account and period, which is of dense. Let's understand why account is tagged as dense. Every single entity, every market, every scenario is going to have value in revenue, cost of goods sold, margin, operating expense, and all other financial accounts. So there is no gap. The data is present across the account in every combination, right? So if we see here, for example, I have taken one sample combination from sparse dimensions. And if we see here, this sparse dimensions combination has value across accounts, that is revenue, COGS, margin, and headcount. Similarly, period is also marked as dense because when the company plans or forecasts, they plan for every month, that is Jan through December. They roll up to quarter, they track year to date. So there is simple no such thing as period with no data, right? So period is dense and it belongs there. So as we can see for this sample sparse combination, we have a data across accounts and across periods. So as a As an example, I've just taken till April, but usually the company will plan for Jan through December. Since the data is highly populated for account and period, that's the reason these two dimensions are marked as dense. Now, on the sparse side, we have year, entity, market, products, plan element, scenario, version, and currency. Right. So all this which are highlighted in amber is sparse. Okay. So why these dimensions are marked as sparse? Let's take a simple example. So I have taken few members from each dimensions. That is, entity has India, US, and Europe, whereas product has laptop, mobile, and tablet. Market has three marketplace, that is retail, online, and wholesale, and scenario and version dimensions. So based on this example, our possible combinations, that is member from each dimensions, will give me 162 possible combinations. So do we really think 162 possible combinations will be having data in all this 162 combinations? Let's see an example. Entity India Ops, if we consider, they sell only two products, that is laptop and mobile, in marketplace, retail, and online, only for plan scenario. Whereas US Ops sells only tablet, Europe Ops sells only mobile with the respective marketplace, right? So as we can clearly make out that not many products or many combinations, many entity combinations are present. That is, all products are not sold in all the markets and in all the entities. That means there are many empty cells where the data never exists or never flows in as well. That's why, since the data is very scattered, it's not dense in nature, we have marked these dimensions as sparse, right? So the same logic applies to the market. And when we take a look at the scenario, for scenario, as we have seen, the data will be present only for this combinations like actual with final version, right? And for forecast, it will be present for forecast and OEP working. And for plan, it will be present in working and the final version, right? Since there is no data, so this is exactly why these dimensions are sparse, because the business reality is selective, not universal. So whatever example we have taken, there are selective combinations. The data are present, not for each and every combination. So the bottom line is why it matters. Why configuring dense and sparse correctly matters. See, if we get our dense and sparse assignment right, our application performs beautifully well. If we get them wrong, then we are looking at a memory problems, sluggish calculations, and users who lose confidence in the system. It really does come down to this one foundational decision. All right, so now we know the names dense and sparse, but let's go one level deeper and talk about what they actually mean when you are working with the real data. A dense dimension is simply one where almost every cell has a value. Let's take account as an example. No matter which entity you are looking at, no matter which market, scenario, or version, we are going to have revenue there. We are going to have COGS, operating expense, net income, and any other financial accounts. All of it will be there. So the data fills up the space that is dense. Periods Period works exactly the same way. Every single period member is part of every planning cycle without exception, because the company plans from Jan through December, that is for all the months. So period is dense, no question about it. Now when it comes to sparse, it is completely a different story. Let's talk about a product dimension. Imagine we have a product catalog of 500 SKUs. That is, it has product dimension has 500 members. I know it sounds like a lot, and definitely it is. But do we really think all the products will be sold in all the entities or in all the regions? Let's see an example. So so let's consider East is selling only 500, only 50 products. So the rest of the 450 products for this East combination will be empty, right? So in this scenario, we need the blocks only for 50 combinations, not for entire 500 combinations, because in that 450 combinations are blank and we never expect the data flow into this combination. And this is where the Essbase does something really smart. So instead of reserving the storage space for all 500 products against every entity, whether the data exists or not, it only creates a block where there is actual data. So for entity East, it creates only 50 blocks. That's the efficiency of the sparse dimension. So to put it very simple, account and periods are dense because every cell tends to be populated. Product is sparse because most combinations are empty, and Essbase is smart enough not to waste the space storing nothing. This distinction, dense versus sparse, is genuinely the most important concept to understand in EPBCS. Everything else we talk about in this series builds on top of it. We now understand what dense and sparse means. Let's talk about what they actually do to your system, because this is where you start to feel the difference in your calculations, in your reports, and in the user experience as well. Let's start with the dense dimension. Because account and periods are done, all 12 months of revenue, COGS, and net income sit together inside a single data block for each sparse combination. So what exactly it means? Let me show you. S- So this is a sparse dimension, right? So here we'll be having entity, product, scenario, version, currency, year, right? So this is one sparse combination, and for this sparse combination, we will be having a data block, and each inside data block we will be having data cells. So how this data cells look? So this can be Jan, Feb, March. Since it's multi-dimension, it is like 3D, right? It's not even 3D, it's multi-dimension. And here you can consider as account one, that is revenue, COGS, operating expense. So each data block will have all the member combinations of dense dimension, right? So when Essbase needs to roll up Jan through December at quarter level or half yearly or year total level, it does the entire operation inside that one block, because all the data are present in this block. It doesn't need to go out of the block, get the data, and then do the aggregation, right? Since everything is present in one single block, it doesn't require any extra disk rates, no additional memory loads. It is all right inside the same block. So this is the reason why dense dimensions are very fast, and that the work happens in one place, right? So when it comes to sparse dimension, it works very differently. Every unique combination of sparse members create its own separate block. So as you can see here, this is one single combination of sparse dimension members, right? So this has one block, and this block is a combination, has a cells of dense dimension combinations, that is account and period, right? So as you can see, inside block there will be a cells for each account period dimension, right? So in case for another example, this is for plan scenario. If I want to create a block for forecast, so if I'm using the same combination but my scenario is equal to forecast, this will create another block of cells inside it, which will be having all the combinations of period and account. Okay, so each unique combination of sparse dimension which has a data will create a block, and inside block it creates a cells for each combination of dense and sparse, right? So for example, say a scenario dimension has 10 members. So our scenario dimension has 10 members. That alone means our block count is 10 times higher than your base. So what exactly that means? Let's take the same example of combination, right? So let's lay out scenario for now. Other than scenario, if we have the same combination for each unique combination of scenario, since we have 10, this combination will repeat 10 times for each scenario, and each scenario will have a block. So blocks will be created based on the sparse dimension. Now if we add version to this, right? So if we add a version and consider version has 5 members. So how many blocks will be created here? 10 into 5. Almost it increases 50 times, right? And now if we consider all 8 dimensions in the same way, and if you want to create blocks for all these combinations, then the block will be exploded. The number grew very quickly, right? So here is a simple mental model to make this stick. If period is dense, which it is and which should be, 12 months live comfortably inside one block per entity per market combination, as it is pictorially represented, right? But imagine for a moment that if we made a period as a sparse by mistake, then can you imagine what would be the structure of the block? So as you can see here, if we make the period dimension as sparse, right? Each sparse combination will create a block. That means for one unique combination of sparse, it creates 12 different blocks for each period member. That is 12 times the block count, 12 times the memory consumption, and 12 times the calculation time. So one wrong decision and our application is working 12 times harder than it needs to be. The same logic applies to years. Keeping years as sparse means each year act as a separate block selector, which is clean and efficient. But if we make year as dense, then what happens? Every unique combination of sparse, okay, that is entity market product combination, would suddenly a five carry all 5 years inside every block. That means previously my block structure was like this, like account and period, since only these two dimensions were dense. Now, since we made year also dense, it will have one more angle of year if it is dense. But we already know that year was sparse because the data was scattered. It's not dense in nature. Since we forcefully make year as dense, the block size will increase for 5 more times, right? 5x. So block size would explode. Performance would suffer immediately, right? So that's why we need to be very careful when we are making or tagging the dimension as dense and sparse. That is really the core message here. Dense and sparse are not just technical settings you configure once and forget. They are the foundation that your entire application's performance is built on. If we get them right, everything runs smoothly. If we get them wrong, no amount of hardware upgrades or tuning will fully save us. So far, we have been talking about block at a conceptual level. Now, let's get into what actually happens inside the Essbase engine and how the block is physically born. Let's walk through it step by step. In step 1, dense dimensions define what goes inside every block. So let's think of a grid which is similar to the data Excel form. So each grid will be having multiple cells. Okay, so in row let's consider as account, and in columns let's consider a period, right? So what will be means how many cells will be present inside a grid? It is a combination of account and period. Since it's dense, it considers each and every member in this two dimensions. So the entire grid contains every row, every column. It's a interior of one single block. So this entire thing is considered a block. So this is what every block looks like inside. Okay. In step 2, let's consider the sparse dimension. Sparse dimensions decide how many of these blocks get created. For example, in our application, we have 8 sparse dimensions, right? Let's consider each dimension has some members like 10 into 10 into 5 into, and it goes on, right? It goes on, and it requires some millions of cells, millions of blocks for each unique combinations of uh, sparse dimension. But in business reality, do we really require this many number of blocks? If we create this many number of blocks, then application would never be alive to work, right? So this is where the Essbase is efficient. A block is only created if data actually exists at that sparse intersection, right? Means like for entity E1 and product P1 at marketplace M1 for FY25. Okay, we have a data. So only for this combination a block will be created, not for all other combinations where we don't feel the data would never ever come into picture, right? So Essbase do not create a block for it. It does not reserve space, not even allocate a memory. So the block simply does not exist until there is a reason for it to exist. Okay. So think of a sparse dimension combination as a postal address. So what exactly mean by postal address? This is the content inside the post. It can be an invitation, you're sending an invitation, or some postal card with some information, right? So this is nothing but your data block with all the data inside it. That is a data cells. Okay, and how do you post it? You just put inside an envelope and write address here. So this address is nothing but combination of sparse dimensions, entity, product, market, year, scenario, version. So combination of these make address, right? So this address will be addressed to a block location. So whatever content is present inside this envelope will be stored or saved inside this block. That is what is pictorially represented here. So imagine if I don't have any content, okay, and still if I put inside an envelope and post it. So does it really make sense to save inside a block? Definitely no. It doesn't even create a block for this empty envelope. That is, if sparse doesn't have any data, if it is empty, then it doesn't create this block at all. That is what the Essbase does. It's very intelligent to decide whether to create a block or not. So once we really internalize this model, we will never again wonder what happens when we change the dimension type, because we know exactly what it does to the block, to the memory, or to the calculation time. So every dense and sparse decision has a direct and physical consequences inside the engine. And now you can see it. This is one of the most important slide in the entire presentation. So I want you to really let these numbers sink in. Let's understand the difference between the potential block and existing block. So what is potential blocks? Potential blocks are every mathematically possible combination of your sparse dimension members. So let's take a simple example. So these are all the list of sparse dimensions and number of members present under those dimensions, right? So what is potential block? So potential block is a combination of all the members in all the sparse dimensions. That comes around 7.5 million blocks, right? So if Essbase had to store all of them, the application would never even start. But here is the beauty of sparse design. Existing blocks. So existing blocks are only those where real data actually been entered or calculated. So for example, if only 50 of 500 products, right? Only 50 out of 500 products are sold in entity East, then only 50 existing blocks are created for that particular sparse combination instead of hundreds of millions of blocks. Hope the concept is clear. So the key design principle is sparse design ensures that only a fraction of potential blocks are ever created. Dense members keep the block interiors efficient and fully populated. So our goal as a EPBCS designer is always to keep the ratio of existing blocks to potential blocks as small as possible. A high ratio, right? If the existing block to potential block ratio is high, meaning most potential block actually exist, which signals that our sparse members are not selective enough and performance will definitely suffer. So we need to monitor this ratio regularly. It is one of the most reliable health indicators for our EPBCS application. So let me show you how we can check the stats. So we need to log in and navigate to rules. In rules, navigate to database properties, expand and click on the cube which we want to check, and click on the statistics tab. Here we can see the potential number of block is there are so many blocks. So do we really require this many blocks? No. So existing level 0 block is only one because I made an entry in only one combination just for a testing purpose, and it rightly showing that I have only one block exist in this entire cube. So this needs to be monitored regularly and make sure the design is right. And that wraps up this video session. So we have now built complete conceptual foundation for EPBCS block storage. We understand what dense and sparse dimensions are, why account and periods are dense, and how blocks are physically formed from sparse combinations, and the critical difference between existing and potential blocks. So in the next video, we are going to take this foundation and explore the engine that runs on top of it. That is intelligent calculation, concept of dirty blocks, upper level aggregation, and dynamic calc. Right. So the advanced mechanism that determines how fast our EPBCS application performs day to day. So join us for the second video to see how Essbase makes your calculation dramatically faster using dirty block tracking and by using dynamic calc. Thank you.